question 4. This is a little bit more challenging than some of the other questions just because there's so many steps. But each of the steps is straightforward. But again, the problem with this question is maybe not knowing where to begin. Right. So we know that if we see a structure like this, and don't even look for a squared because it could be any constant, because any constant is really a square number. So we're thinking about this structure in terms of trig. If we see 1 minus x squared, we're thinking sine and cosine. 1 plus x squared, we're thinking secant squared and tangent squared. And which way does that go? Well, again, x squared plus y squared equals r squared. I'm always forgetting these. You should probably just write them down. And then you divide by x squared, and that's 1 plus tan squared is secant squared. Okay? So that's on your crib sheet. So that is the driving force behind the whole solution here. We want to let x, we want to replace it with something. So when it's squared, you get a 4. All right, so x squared is going to have to be 4 tan squared, and so that means x has to be 2 tan of theta so that we can make this trick work out. Let's see, x squared plus 4 is going to be 4 tan squared plus 4, which is going to be 4 secant squared. Then we're going to take the square root of that, and so then that is going to equal to 2 secant theta. Alright, so now we don't need this formula. We're well on our way. Okay, so we have a lot of pieces here. But one thing we don't have is we don't have our dx. So from here we get dx, derivative of tangent is secant squared. And that's something that if you don't have memorized, just put it on your crib sheet. And then there's all sorts of pieces. Now, a lot of times when we do u substitution, we jigger with this. We do something to it. But we don't have to. We can just drop stuff in. So let's just see the pieces. We have a dx. It's right there. We have an x squared right here. And let's see. We just basically have everything we need. So let's go ahead and start assembling it all. And so the dx is 2 secant squared theta d theta, and x squared is 4 tan squared theta, and this square root mess is 2 secant theta. Okay, so luckily we can get rid of one of the secants and we can get rid of the 2. And then what do? Well, this is secant theta d theta over 4 tan squared theta. If you're stuck, that's okay. This is what I consider to be the halfway point of the problem after looking at many examples of student work, and I concluded that this was worth half the credit for the problem. So I can't tell you in advance how much each step is going to be worth. I have to just look and see what the class as a whole does, and based on sort of peer voting, I try to figure out where the halfway point is. But if you get this far, you might think to turn everything into sines and cosines. Alright, so tangent is sine over cosine, and secant is the reciprocal of something. What is it? You get sine, cosine, tangent, cotangent, secant, cosecant. There they are paired up with their reciprocals. So it's 1 over cosine. Okay, so that's just a little way of remembering who goes with what. So let's reassemble everything. Secant is 1 over cosine. So we're just going to put him in the denominator. And tangent is sine over cosine. Okay, now what? Well, one of the cosines cancels out. Let's go ahead and rewrite that again. Then we have 4 sine squared theta. Great. Now what do? Well, now we can use good old u substitution because u is sine of theta. Derivative of sine is cosine. And we're going to put all this stuff back together again. So we have a du on top and a 4u squared. And then this could be equal to, let's rewrite this, 1/4 u to the minus 2 du. And how do we integrate that? Well, we're going to increase the power and divide by the new power. Let's double check. If we go this way and take the derivative, do we get back to 1/4 u to the negative 2? Yep, we do. All right, so we're happy with that. And we could add the plus c right now if we want. We're not really done. We may think we're done, but we're not done. U, what did we say u was? U is sine of theta. And we say now we're done. No, we're not done, unfortunately. And at this point, I decided that this was 3/4 of the way through the problem. People who got this far got like 9 out of 12 points. Okay, but there's still more work to be done. And that's because we did this thing up here, x is equal to 2 tangent of theta. So x is equal to 2 tangent of theta. So x over 2 is tangent of theta, and that means theta is an angle whose tangent is x over 2. And then we need to take the sine of that guy. Well, what is that guy? Right. I should draw myself a triangle. So if this is theta, theta is an angle whose tangent, so tangent is y over x, but y is x and x is 2. So if you're a SOHCAHTOA person, you're in heaven now because you're saying, aha, TOA, tangent is opposite over adjacent, and I didn't have to worry about saying y is x and x is 2. Okay, so you win. Okay, I don't like SOHCAHTOA, but I have to say in this example right now, it makes a lot more sense than remembering x, y, and r. Okay, so now what we need is sine of theta. What is sine of theta? In this case, opposite over hypotenuse. There we go, we have a hypotenuse. Or if you're me, y over r, but y is x. Sorry about that. There we go. That is sine of theta. Okay, but we're going to actually take the reciprocal of the sine of theta. So it's 1/4 times the reciprocal of this mess plus c. And that is the whole integral. And this is the answer. Okay, and that will be full credit if you get all the way to there. And I've got to figure out how to shut this off.